Welcome to all the participants this afternoon. The topic this afternoon is science and spirituality should not be separate. Our speaker this afternoon is Kenneth Chen. We are the honor to host Kenneth Chen, who holds university degrees in both medicine and physics and has formerly worked as a doctor in Singapore and as a scientific editor for World Scientific. He is a follower of the Tibetan Buddhism and has been a Rosicrucian for 30 years. He wrote an original scientific paper on the theory of relativity entitled Time and Space, which was approved for publication by Kip Thorne, the Physics Nobel laureate in 2017. The paper explains for the first time why the speed of light is constant, based on his understanding of both relativity and human physiology, and was published in 1993 in ISPE Anthology, Thinking on the Edge. In 2004, he published Quintessence of Dust, The Mythical Meaning of Hamlet, which shows how Shakespeare meticulously crafted every part of the play to convey a deep spiritual message. The book was nominated for the Book of the Year award by Forward magazine in 2004. In 2016, he wrote an online article, Why Relativity Exists, which presents the key findings of his paper, Time and Space, to a general audience. It emphasizes that consciousness is a critical component of our reality. In the same year, he also wrote another online paper entitled A Direct Experiential Interpretation of Quantum Mechanics, which shows how the Buddhist Madhyamika philosophy solves the mystery of quantum physics. In 2021, he published an online article entitled The Spiritual Path, which shows the remarkable synchronicity between Madhyamika philosophy, the Noble Eightfold Path, the Kabbalah Tree of Life, and the Tarot. This synchronicity revealed that the different spiritual traditions draw the inspiration from the same source, and together provide us with a map depicting the stage of the spiritual quest on the path to enlightenment. Science and spirituality should not be separate. The scientific evidence from relativity and quantum mechanics shows that our human consciousness is an integral part of our science. This means that the widespread scientific view that this is a materialistic universe is incorrect. Also, our consciousness cannot be purely derived from matter. Participants, the floor is handed over to Kenneth. Kenneth, welcome. And we look forward to spending some wonderful time with you.
All right, thank you. Yeah, first let me say it's an honor and privilege to be here. So thank you for letting me talk to all of you. This is a topic that is very important to me. Okay, now the talk will be in two parts. The first part deals with relativity, and the second part with quantum mechanics. Are you all seeing the share screen?
No, not yet.
No, not yet. Okay, hold on. Let me just bring it up. Okay, are you seeing it now?
Yeah, confirmed. We
Okay.
hear you, we see you, we see the slides.
All right, so I can go ahead then. All right, the aim of this talk is to address one problem that the world faces, and that is that the current scientific view of a materialistic universe is the wrong framework for guiding our actions and decisions in life. This unfortunate perspective of a materialistic world is actually a misconception, and it's caused by scientists rejecting, perhaps inadvertently, what the scientific evidence is actually telling them. Now, I say perhaps inadvertently because I'm not suggesting that they are deliberately rejecting scientific evidence. Generally, scientists don't do that, but they have been taught to think in this way. And unfortunately, essentially, it does mean that they are rejecting the scientific evidence. That's what I'm going to point out in this talk. Okay, this scientific worldview is unfortunate because a purely materialistic worldview leaves little room for spirituality. So it is therefore important to replace this erroneous view with one that does correspond to what our scientific evidence is actually telling us. This is part of the process to establish a more spiritual state in the mundane world. Science and spirituality should not be separate. Okay, now the talk's in two parts. The first part is on relativity. But let me say from the outset that evidence from quantum mechanics is far more compelling. But we will start with relativity. Okay, so what is relativity? First, let me say that relativity, together with quantum mechanics, form the foundation of all modern physics. In other words, all of modern physics is based on these two theories, relativity and quantum mechanics. And the theory of relativity tells us that time and space distort in complicated and bizarre ways, depending on the state of motion of the observer. We get things like time slowing down, length contracting, and even simultaneity becomes a relative thing. What that means is that one observer may find, say, event A happening before event B. Another observer may instead find event B happening before event A. So all this is very bizarre, but it has all been verified experimentally over the last century. So that raises a question. Why does this distortion of time and space occur? It is a very strange thing. And also, how did Einstein arrive at this seemingly fantastic conclusion that time and space distort in this bizarre manner? Okay, one cartoonist I saw had this suggestion. All right, he's saying if it's not E equals MA squared, not E equals MB squared, so what's next? All right, I don't think Einstein actually did that. What he actually did was this. The whole theory of relativity begins with two postulates. Now, a postulate is something like a proposal. It's a proposal of physics laws, or in maths, they will be called axioms. And from these two postulates, Einstein derived all the conclusions pertaining to relativity. So let's have a close look at these two postulates. The first one essentially says, well, that's the one that gave the name to the theory, relativity. What it essentially says is that all states of motion are relative. For example, if you are standing on a train station and you're watching the train travel, say, to the right, yeah, well, everyone will say, well, you're right, yeah, but according to Einstein, the guy on the train, okay, provided he's not accelerating, if he's traveling at constant velocity, yeah, the guy on the train is equally correct to say that, no, I am the one who's stationary, you on the station platform is traveling to the left. And according to Einstein, both are correct. All right. What it says actually is that all the laws of physics are the same in every inertial reference frame. Now, physicists prefer to use reference frame, the term reference frame instead of observer. But it is the reference frame of the observer. They like to leave out the observer as much as possible. Okay, but they really can't. Yeah, inertial simply means this observer is not accelerating. He's traveling at constant speed. Okay, so that's the first postulate. Now, this was a revolutionary way to think about things, but it's kind of logical, you know, it makes sense. Yeah. So that's the first postulate that gave the theory its name. Now, the second postulate is really weird. All right. Now, this one involves the speed of light. And what it says is that the speed of light in a vacuum is always measured to be constant, no matter how fast the observer is moving or how fast the source of light is moving. All right. It doesn't sound strange when you put it like that, but it really is weird because it means no matter how fast you chase after the light ray, it's still traveling from you at the same speed. Now, let me illustrate how weird this is. Okay, I'm going to use an analogy here. We see a police car chasing a getaway car with all the crooks in there. All right. And let's say you are watching this from the sidewalk. Okay, you can barely make out this guy, but he's watching it from the side of the road. And what he sees is that the getaway car is traveling at 100 kilometers an hour, and the police car is chasing after it at 90 kilometers an hour. It's slightly slower. All right. And what he sees is that the gap between the police car and the getaway car is increasing by 10 kilometers an hour. All right. This makes sense, right? Now, imagine the getaway car is behaving like the speed of light. Then what we will find is this. You on the sidewalk will say the gap between the police car and the getaway car is increasing by 10 kilometers an hour. The police in the police car will instead say, no, as far as we can tell, the gap between us and the getaway car is increasing not by 10 kilometers an hour, but by 100 kilometers an hour. Because the speed of light is always constant, and the getaway car, if it's behaving like the speed of light, that's what it will do. Well, that's how weird it is. So the first time I heard anything like this, I thought, hey, that's bonkers, this is not possible. Yeah, but that's the theory of relativity. That's the second postulate. And it has actually been experimentally verified that the speed of light is always constant to all observers, no matter how fast they're moving. So how is this possible? It doesn't make sense, right? Einstein came to the conclusion that there is one way it could be possible, and that is when you're moving fast, like you're in the police car, your time and space distorts. So it is the distortion of this time and space that allows the speed of the getaway car to remain the same. So both you on the pavement and the police in the police car will see this guy, the criminal in the getaway car, running away from them at 100 kilometers an hour, the same speed. It's because of the distortion of time and space. All right. Now, let me just tell you, this distortion of the time and space is not something simple. It's actually bizarre and very complicated. Yeah. Here are two equations which showed, which tell us how they distort. Now, if you know anything about maths, this is the time that has been distorted, and it depends on the original time, but it also depends on the position. So the distortion in the time varies depending on where you're standing in the other frame of reference. So it is very complicated and bizarre. And the space distortion is equally bizarre. All right. Now, that raises the question, why is nature behaving like this? Okay. In other words, why does relativity exist at all? Yeah, because we have a case where time and space distort in very complicated, bizarre ways, depending on the motion of the observer. But we notice that there is, as Shakespeare would say, there is a method to this madness. They all distort in exactly the correct way so that we will always measure the speed of light to be constant. Why should it be doing this? Now, it almost appears like an elaborate conspiracy by nature to fool us into thinking that the speed of light is always constant. But really, why would nature behave like this? Yeah. So if we take 2 steps back and we look at this again, we will ask this question, well, is there really a conspiracy by nature? There is this joker in the sky who's trying to con us? Or are we actually seeing things wrongly? Okay. Now, this next picture tells you what I think is happening. Yeah. I think you all know what the saying is, right? And it's this: have we put the cart before the horse? Now, let's take stock of what's happened here. Time and space distort in complicated, bizarre ways. depending on the motion of observer. But all the time, the speed of light is constant. Yeah. So we really got to ask this question. Since time and space distort while the speed of light is always constant, which is actually the fundamental entity? Now, this is the crux of the matter. If we imagine that there is this universe that science is exploring that is out there independent of us as observers, we would naturally think that, well, time and space must be the fundamental entity. Everything else is sort of built upon this framework. Yeah. But if we don't have this kind of preconceived notion, yeah, and we look at things again, one stays constant all the time, the other one distorts in really bizarre ways, just so that the speed of light remains constant. So if you look at it that way, it becomes very clear that actually it's the speed of light that is the fundamental entity. All right, now that raises another question. So why is the speed of light the fundamental entity? Okay, the answer will be quite surprising. Okay, I've put it in red here. It is because the theory of relativity would not even exist if not for the way our human body functions. Now, this sounds surprising to a lot of people. They sound like things coming from two completely different fields. So how do we come to such a staggering conclusion? Okay, we'll have to look at this closely. Yeah. But first, let me say the speed of light is the rate of electromagnetic transmission. And this rate is fundamental to how we experience the universe because our human physiology functions via electromagnetism. Okay, I've studied human physiology in great depth, and I know this is true. All right. This means that the rate of electromagnetic transmission determines the rate at which our body, including our brain, functions, and hence actually determines how we experience time. Yeah, the physiological basis of relativity stems from the fact that all our biological mechanisms function via electromagnetic interactions. Every single organ, as well as every single cell in our body, functions through electromagnetism. Now, let us look at this a bit more closely. First, what is electromagnetic transmission? Okay, we come to this diagram. Now, if you have done basic chemistry or physics, you'll know that if you have a positive charge and a negative charge, they will attract one another. Yeah, and the force of attraction depends on the distance between them, right? Now, okay, so we got to ask this question. Supposing I were to move this positive charge closer to the negative charge, all right? Now the distance is smaller. The force felt by the negative charge will be bigger, right? Okay, the question is this. When does the negative charge experience this change in the force? Does he feel it the instant we move the positive charge closer? Or is there a time delay? Okay, it turns out there is a delay. You may move this closer. This guy here doesn't feel the change in the force immediately. There is a delay. And what the scientists will say is that there's a distortion in the electric field, and this distortion takes time to travel to this other object. Okay? The rate at which this distortion travels is the rate of electromagnetic transmission. And it turns out that's exactly the speed of light, because light is actually distortion in the electric and magnetic fields. It's an electromagnetic wave. So they're one and the same thing. The rate of electromagnetic transmission is the speed of light. Okay. Now, if our entire body functions on electromagnetism, that means this rate of transmission actually governs how different parts of our body interact with each other. It governs how different parts of the cell interact with each other. Now, the simplest illustration of this is can be seen if you look at nerve cells. Now, this is one nerve cell, and this is another nerve cell, and they communicate with each other through this part of the cell known as the axon. What essentially happens is an electrical signal gets passed in this axon to the next cell. Yeah. Now, what causes the electrical signal? Actually, it's caused by ions moving in and out of the cell membrane here. And the ions moving in and out in one part will trigger off the ions in the next part to move in and out. And this causes the electrical signal. So clearly, this is dependent on the rate of electromagnetic transmission, right? Now, if nerve cells communicate like that, it also means that our brain communicates like that. The whole of the brain functions through electromagnetic signals. Electrical signals, I should say. Well, this is obviously true because we can actually measure it. This is an EEG, or electroencephalogram. It measures the electrical activity in our brain. All right. But it's not just our brain that does this. Every part of our body functions in a similar way. Yeah, there's a brain, and particularly our sensory apparatus, our eyes, ears, and so on, they also function through electromagnetic phenomena, and includes our lungs, our muscles, our heart, kidneys, everything actually. And how these organs communicate with each other is also through electromagnetic phenomena and will depend on electromagnetic transmission. All right. So we come back to the physiological basis of relativity. It really stems from the fact that our whole body functions via electromagnetic phenomena. And muscular force is actually electromagnetic force. Yeah. The muscular contractions are mediated by electromagnetism. So we literally move and breathe via electromagnetic interactions. Our sensory apparatus also relies on electromagnetic interactions. Even the nerves transmit information via electromagnetism. So the rate at which our brain functions, which also controls the rate at which we think, is also dependent on electromagnetism. So that means our sensory experience of the universe is mediated by electromagnetism. And that actually explains why the speed of light is always constant. It is because of a limitation in our perceptual ability. We are unable to experience the speed of light varying because both our perceptual apparatus and our brain function via electromagnetic transmission. In other words, we cannot experience the speed of light to be anything other than constant because the very rate at which we ourselves function depends on the speed of light. Okay, let me go into this a little bit deeper with an analogy. What we are doing is, when we measure the speed of light, is something like this. Suppose we want to measure the expansion of an iron rod being heated inside an oven. And we use an iron ruler inside the oven to make the measurement. Well, we are going to detect no expansion, right? This is because the iron ruler expands by the same proportion as the rod. And the iron ruler is incapable of detecting a change because it is also inside the system and equally affected by it. That is why the speed of light is always constant. It's constant because that's the way we experience the universe. Now, here's another analogy. This is a water wheel being turned by the running water in the river. Okay, what we are doing is actually we are using the turns of the water wheel to define our time. Let's say we say, okay, maybe one turn represents 1 minute. All right, and now we are using this time defined by this water wheel to measure the speed of the water flow in the river. Now, again, you'll see that we're going to always find it to be constant, because if the river travels faster, the wheel turns faster, and they're both increasing at the same rate. And we will always find it to be constant. Here's another analogy. All right, I think some of you might know these characters. Comes from the film Jumanji. Now, in the film, all these characters are somehow trapped inside a video game. Okay? So what I'm saying is that we are like these characters trapped inside a video movie. Now, if someone were to slow down the movie and we are inside it, yeah, we wouldn't be able to tell the difference because everything slows down, including the way we move, the way we think, the way we function. We wouldn't notice the difference. And that's what is happening. And that's why the speed of light is always constant. All right. Now, this tells us something very important about our science. If you recognize why the speed of light is constant, it reveals one very important fact about the nature of our science. Our science is not a science of a universe out there, independent of us as conscious observers. It is actually a science of how we, human observers, experience the universe. If you think about it, we actually don't have access to a universe that is independent of us, because all our scientific data comes from our human observation. Even our scientific machines, we need to observe the data from them. So it all ends up with observed data. Yeah, unobserved data means no data. And all our science actually is a science of the data we observe. And so it is a science of a universe that is experienced by us, not the science of a universe out there independent of us as observers. Yeah. And what relativity is telling us is that actually we have arbitrarily defined time and space according to how we experience them. There is actually no time and space existing out there in a universe independent of us as observers, because time and space is actually how we experience it. Yeah. So in a sense, we cannot measure the speed of light in a vacuum as anything but constant, because we are essentially trapped inside the system, like the characters inside the video movie. Yeah. If someone slows down the movie, we wouldn't notice the difference. Yeah. How would we notice the difference? Because we are all slowing down at the same rate. And the problem is the characters inside the video movie cannot escape the system to view it from the outside. So we are really in this kind of situation. Now, I think a lot of you will recognize what this depicts. It's Plato's allegory of the cave. Yeah. Those who are not familiar with it, what the story is that there are these prisoners who have been chained up, and for all their lives, and all they can see are shadows on the wall. Someone's projecting these shadows on the wall, and that's all they see. So that's all they've been seeing their whole lives. They come to the conclusion that this shadows on the wall is the sum total of reality. Yeah. What they don't realize is it's because of a limitation to their perceptual ability. That's what's causing this. And what relativity actually tells us is that we are actually in this kind of situation. We cannot measure the speed of light to be anything but constant, because we are also trapped inside the system. Yeah. But why I'm pointing this out is that it is important that we realize they are in this situation, because if we don't, we would not look for ways to expand our horizons. Yeah. Because we would assume that this materialistic universe that we see outside is the sum total of reality. Well, actually, it's not, because of the limitation in our perceptual ability. All right. So the conclusion we can draw from relativity is this. This actually comes from my paper, the last two paragraphs. I'll just read it. Acknowledging the role of the observer means that we need to study closely the mind and the attributes of the observer, through which all our scientific information is obtained. And that means taking into consideration our human physiology, our human perceptual abilities and limitations, and particularly one aspect of the human observer that is poorly understood in scientific terms, but which plays an overarching role in our experience of the universe, and that is our consciousness. A science that ignores consciousness or artificially relegates the conscious mind to that of a secondary and hence unimportant phenomenon is actually an incomplete science, because all our scientific data relies on the conscious mind as a necessary component. Both relativity and quantum physics tell us that we cannot blindly assume that the conscious mind that experiences what constitutes our scientific data has no effect on the nature of the data itself. So, a discipline that willfully chooses to ignore the conscious mind as a vital component of our reality must be viewed at best as an artificially restricted discipline, or at worst, as a distortion of the truth. Okay, that is the end of the first part of my talk. Yeah, the next part we will go into quantum mechanics. And as I said, that's even more compelling evidence. All right, maybe I'll stop sharing this one. And all right, should I just continue straight into the next part, or does anyone have anything compelling they need to ask me about?
No. I think that would be the best way. If you wish to continue the second part,
Yeah, okay.
and then we can try it all together, and the questions may come from both trying to understand both presentations at the same time.
Okay, good. Yeah, just give me a moment. I'll have to send up the. Okay, can you see this screen now?
Yes, we can. Yes. No
Okay,
problems.
good. Yeah. Now, all right. This part is about quantum mechanics, and I'll dive straight in. Yeah, into the formulation, the mathematical formulation of quantum mechanics. Yeah, how it works is like this. Yeah. If you want to find out something about a particle, an elementary particle, let's say an electron, yeah, all that can be known about the electron is encapsulated in a mathematical entity known as the quantum wave function. Okay, a mathematical entity may be something like a number, a vector. In this case, often it's represented as a matrix. All right, and to obtain this information about, let's say, the electron, let's say we want to know its position, yeah, we apply what is known as an operator to the quantum wave function. An operator is simply a mathematical procedure that enables us to obtain, now this is important, a probability distribution of the possible outcomes of a measurement by an observer. Okay, now this needs a little bit of explanation. When we apply this operator to the quantum wave function, we get a probability distribution of the possible outcomes if and only if we make a measurement. Now, the first thing to notice is that at the very outset of the quantum mechanics, the observer is involved. Yeah. And what we obtain is, let's say we are looking for the position of the electron. Okay. When we apply the operator, what we will get is not the exact position of the electron. You will get instead a probability distribution. And it looks like that. It will tell us that, look, if you were to measure the position of the electron, there's a 30% chance you'll find it in one position, position A, maybe a 20% chance you'll find it in position B, and maybe another 25% chance you'll find it in position C, and so on. So that's what we get. It's a probability distribution. Now, there's something odd about this probability distribution, which we need to understand. It's not like the probability of that we calculate, let's say, in a casino. Supposing you throw a dice and you put a cup over it. Yeah, we will say, well, there's a 1/6 probability that it's showing, say, the number 5. Okay. We give that as a probability because we actually don't know what it's showing. It's our ignorance. That's why we give it a probability. Now, the probability distribution in quantum mechanics is not like that at all. Now, when we get the probability distribution of, say, the position of the electron, yeah, 30% chance here, 20% chance here, and so on, yeah, it is not because we don't know where the electron is. It's because the electron has actually not decided where it is. That means it doesn't actually manifest at any position if we don't measure it. This is the oddity about it. So it's like a spread out thing. Yeah, in fact, it doesn't even manifest unless we measure it. When we don't measure it, it remains as a probability distribution, the quantum wave function. All right. So this is the peculiarity of quantum mechanics. Yeah. Okay. And the important thing to note is that right at the outset, it involves measurement by an observer. It doesn't give us information about the particle per se. It only gives us information about what we might find if we, human conscious observers, make a measurement. Okay, now you can see why physicists have so much trouble trying to get rid of the observer from quantum mechanics, because it's there right at the very beginning, and they have been trying for over a century to get rid of the observer, and they have failed. They are still trying, but as far as I know, they still haven't succeeded. Yeah. All right. So this is the basic formulation of quantum mechanics. Now, just note that if we want to measure a different property of the particle, let's say we want to measure the momentum, we use a different operator. So different things we want to measure will result in a different distribution, probability distribution, depending on what we measure. Okay, now this is a strange way that nature behaves. And that prompted Einstein's famous statement, God does not play dice with the universe. Einstein was never happy with quantum mechanics all his life. He spent the later part of his life trying to show that either there's something wrong or it's incomplete, because he couldn't accept that all we can get is a probability distribution. And this is what Niels Bohr is supposed to have responded, says Einstein, stop telling God what to do. All right, now let's look a bit closer at what is happening. Now, in my paper, I use this analogy. It's like a cutting a birthday cake kind of thing. Yeah. So the quantum wave function is like a cake. It contains all the information on the particle. When we apply an operator, that means when we want to find out what kind of outcomes we will get if we make a measurement. Yeah. The operator is actually like a set of instructions on how to cut the cake into slices. Yeah, different operators will give different instructions on how to cut the cake. One may say cut it up into rectangular slices. One may say cut it up into triangular slices. Okay. Now the thing is the maths actually works like this. Yeah, each slice that that results when we apply the operator represent a possible outcome of a measurement of the particle, and the size of the slice represents the probability that that particular outcome will be the actual outcome if we measure the particle. That means it gives us the percentage, maybe it's 30% or 20% and so on. The size of the slice gives us that. Now, here's the really important point. If we do not actually make a measurement of the particle, let's say we do not actually measure the position of the electron, this cake remains uncut. It just gives us the instructions and we can tell the size of the slices, but the cake is still not cut. If we actually make a measurement, then a dramatic change occurs. And this change is called the collapse of the wave function. Essentially, it means we actually cut the cake into slices. All right, that's the collapse of the wave function. Now, we need to look at this more closely. What is the collapse of the wave function? Yeah, this is an abrupt and discontinuous change that occurs to the quantum wave function, the cake, if and only if an observer makes an actual measurement and observes the result. This is the really odd thing. Now, if no measurement is made, the quantum wave function just evolves in a continuous and orderly fashion according to an equation known as the Schrödinger equation. And this is predictable. We can tell what will happen to the quantum wave function because it obeys this Schrödinger equation. Now, if we make a measurement, something very different happens. We get this thing known as the collapse of the wave function, which is akin to us actually cutting our cake. Now, and not only do we cut the cake, we find that only one slice of the cake then survives. The rest of the cake disappears. In other words, the quantum wave function has dramatically changed. The surviving slice becomes the new cake or the new quantum wave function. So in other words, the very fact that we make an observation changes how reality manifests. Yeah. So this is the thing that disturbs scientists the most. It means that the observer can actively alter our reality simply by making an observation. So in other words, the reality that we see are actually partly affected by us making the observation. If we don't make the observation, something different happens. If we make the observation, it changes the thing. Okay, that's how odd quantum mechanics is. And that's why I say this is even more compelling evidence that our conscious mind plays an active role in our reality. Because here, we are not just passively observing reality, we are actually changing it. All right? Now, how do we interpret this thing? Okay, the first interpretation is known as the Copenhagen interpretation, and it's started by these two men. This is Werner Heisenberg, and this is Niels Bohr. I think they came to this conclusion at the Copenhagen conference, and that's why it's called the Copenhagen interpretation. Okay, this is what it says, okay? All right, well, this is just the beginning of it. Yeah, no, this is what Niels Bohr says. Okay, in blue. It says there is no quantum world. There is only an abstract quantum physical description. It is wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature. In other words, he is agreeing that our science is not the science of a universe out there independent of us. It's the science of how we experience the universe. All right? And okay, the actual interpretation goes like this. Yeah, this is Werner Heisenberg writing it. Okay, what he says here essentially is that he's talking about 3 steps, yeah? If we make a measurement of, say, the electron, that's the first step. We get the first probability function. Okay, that's actually the quantum wave function. He calls it a probability function here, all right? Then in between this and the subsequent measurement, yeah, we can follow this through the course of time because the quantum wave function obeys the Schrödinger equation. And then the third step is we make a new measurement, and then we can find out where the electron is in the third step. Now, the important thing in what he's saying is that there is no description of what happens to the system, in this case, our electron, between the initial observation and the next measurement. So in between, we can't say the electron is actually here, 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 only we don't know. It actually hasn't decided where it is. When we make a measurement, it decides where it is. In between, it doesn't decide where it is. Then when we make a subsequent measurement, it again decides where it is. So in between, we cannot, there's no description of what happens to it. It's just given by the quantum wave function. That's how weird it is. And it is only in the third step, that is when we make a measurement, that again, it changes from the possible to the actual. Possible, he's talking about the quantum wave function. That tells us the possibilities of where it could be. But it only becomes the actual position when we make a measurement. Yeah. So between the two measurements, we only have the quantum wave function. And only upon the second measurement does it actually manifest itself as an electron at a certain position. All right. How does this show up in experiment? Okay. Now, the easiest way to demonstrate is what is known as the double slit experiment. Now, here we are sending a wave through the 2 slits. Let's say a light wave. Now, waves behave in this way. If we send a light wave through here, we will end up on the screen what is known as an interference pattern. That means we get a bright fringe, dark fringe, bright fringe, dark fringe, bright fringe, dark fringe. Okay, that's what happens in waves. Okay, this is seen also if you send water waves through it. Yeah, because where the crest of the wave combine with each other, you get a lot of energy, and that corresponds to the bright fringe. Where they cancel each other out, that means the crest of the wave corresponds with the trough of the other wave. Yeah, they cancel each other out, and there's very little movement, and it becomes a dark fringe. So that's what happens when you send waves through 2 slits. All right, that's classical physics. It's nothing to do with quantum mechanics. Now, what happens if we were to send electrons through these 2 slits? All right, now an electron is a particle, right? If you shoot one electron, you get one dot on the screen. And we would expect it should be like shooting bullets through these two holes. The bullets that pass through the slit on the left should form a patch on the left. And the bullets that pass through the slit on the right should form a patch on the right. Yeah, that's what we expect from particles. But when we shoot electrons through these two slits, we strangely get an interference pattern instead. That means we get regions where there are a lot of electrons, then next to it there's no electrons, then there's plenty of electrons, then there's no electrons, then there's plenty of electrons. It's an interference pattern. That's what we expect from waves. But hey, we are sending electrons. They are particles. How does this occur? Now, if we shoot electrons one at a time, this also happens. Now, this is what will happen. If we shoot an electron, we get one dot on the screen. One electron, one dot. So it must be a particle. If we keep firing electrons, it will appear like that. If we keep firing more, it will end up like this. And in the end, we will see something like this. That means we get regions where a lot of electrons end up and regions where very few electrons end up. That's an interference pattern. That's supposed to happen with waves, not with particles. So what's going on? Now, yeah, we'll have to spend a little bit of time on this. Yeah, this is what happens with waves. If we shoot bullets through, this is the kind of distribution we should get. Yeah, but if we shoot electrons, we get this instead. That's very strange. So what's happening? Now, it almost appears like the electron is passing through both slits and they're interfering with itself and forming an interference pattern. Okay, now you can see how this links in with the formulation of quantum mechanics. This occurs if we do not observe which slit the electron passes through. And because we are not making the observation, the electron doesn't decide where he is. He doesn't decide which slit he goes through. Yeah, so it's behaving like a wave and passes through. Of course, when it hits the screen, we are making an observation. All right, then it has to decide where it is, and we see them as dots on the screen. All right, so now, okay, this is very strange. Yeah, so being physicists, we would like to check what's going on. Now, supposing we put a detector near one of the slits. So we say, aha, now we will look and see which slit the electron goes through. Right? Now, a strange thing happens then. Once we have the detector in place, which means that we can tell which slit the electron goes through, it doesn't form this interference pattern. It forms this. It's like the electron knows, okay, now you're observing, we are not going to perform this interference pattern trick. We're going to behave like particles. All right. If we remove that apparatus, again, it will form this kind of pattern. It's like the electrons are saying, okay, now he can't tell which slit we're going through. So we do our interference pattern trick. Okay, now if that's not weird enough, yeah, there's a scientist, very famous physicist called John Wheeler. He set up a device where he says, okay, now we're going to outwit the electrons. We make them hit the screen first, and then we put our detection device, which can then, from deduction, tell us which slit the electron went through. But no, we make the electrons hit the screen first. Okay? So now we're going to fool them. But guess what happens? Well, it's a bit like you're putting a detection device behind the screen. We let them hit the screen first, and then we will take note of what happens, and then we can deduce from that which slit we went through. Once that device is in place, the electron does this. It doesn't do the interference pattern. It's almost like the electron is saying, hey, look, they're watching from behind the screen, so we won't perform. We will now behave like particles because they can tell which slit we went through. We have to decide which slit we went through, so we'll do this. Now, okay, that's weird because we made the electrons hit the screen first. Now, if that's not weird enough, it gets even stranger. Now, there's been experiments now where they have this device which detects the electrons after it hits the screen, but then they put another device next to it so that it scrambles the information from this device. In other words, the device is in place, but now the human observer can't tell which state they went through, because there's another device which scrambles the information. Yeah, the information is all messed up. So now again, the observer cannot tell which state they went through. And guess what happens? Once this additional device is in place, it's called a quantum eraser, by the way. Yeah, because it erases the information. Once this thing is in place, the electrons form an interference pattern again. It's like, well, they don't care that the device is there. What they care about is that us human observers can't tell which slit we went through. So, okay, if that's the case, we can do this, because we don't have to decide which slit we went through. Now, that's quantum physics for you. So I hope you can tell that the thing that makes the difference is whether the information is available to the human observer or not, the conscious observer. In other words, it would certainly appear like it is the conscious mind that causes the collapse of the wave function, meaning it's the thing that causes the particle to decide where it is. All right? Unfortunately, the physicists all want to deny this. They don't like the conscious mind being part of physics. All right? And even right at the beginning, at the Copenhagen interpretation, they already tried to deny the role of consciousness. Yeah. Now, while they acknowledge that the observer plays a role, they insist that it must be a passive role. We can't have the conscious mind causing the collapse of the wave function, because that will mean that we actually can change our reality simply by observing it. So what they came up with is this thing called a microscopic macroscopic divide. In other words, they're saying somehow, yeah, when the electron, which is a microscopic object, interacts with a measuring equipment, it is a macroscopic object, it triggers off the collapse of the wave function. Now, this is all kept very vague, and nobody is very sure where exactly is the boundary between microscopic and macroscopic. But nonetheless, that's what they say. It's an attempt to deny the role of consciousness. But as you notice in red here, there is a problem with this kind of ad hoc addition to the theory. Note that this microscopic macroscopic divide is not part of the original quantum mechanics formulation. It's added on. All right. And actually, it doesn't work. And why it doesn't work is because of this. This is called the von Neumann chain. Von Neumann is one of the pioneers of quantum mechanics. He's the guy that set up the mathematical foundations of quantum mechanics. And what he says is this: the device, the measuring device, cannot cause the collapse of the wave function because the device itself is composed of elementary particles and hence must also follow the principles of quantum mechanics. So what he reasons is this, and this is correct. It can be shown to be true. Yeah, when the measurement apparatus interacts with the object, it becomes what's known as entangled with the measurement. The object becomes entangled with the measurement apparatus. It's called quantum entanglement. And what this means essentially is now that the system of the object and the measurement apparatus now forms a bigger quantum wave function. Yeah, there is still no collapse of the wave function. Yeah, so if you have the measurement object observing the electron, both of them become entangled and becomes another quantum wave function. It's still a probability wave. The electron has still not decided where he is. Okay, and what von Neumann reasons is this: in order for there to be a collapse of the wave function, there must be a break or a cut. Okay, he wrote this in German. It's called Schnitt in German. And he says this break must be achieved by an entity that is different from the systems that are composed merely of elementary particles, which means it's something else other than elementary particles. And he says it must be our subjective perception. That means it's the consciousness that causes the collapse of the wave function. Okay, and this shows that this microscopic macroscopic divide actually doesn't work. because the macroscopic measuring apparatus doesn't cause the collapse of the wave function. Yeah. Eventually, it has to be something that's different, something from just the materialistic elementary particles. Well, here's an illustration of the von Neumann chain. Yeah. Okay. Let's say we're looking at an electron with a microscope, and this whole system becomes a bigger quantum wave function. And if you're watching it, okay, the photon is then sent to our retina, but okay, it hasn't reached our mind yet. This whole thing becomes entangled and it becomes an even bigger quantum wave function, but there is no collapse of the wave function. So eventually it will reach the conscious mind. And that's where, in all likelihood, that's the thing that causes the collapse of the wave function. All right. And in the 1960s, this guy called Eugene Wigner, he's a Nobel laureate in physics. He came up with a paper which point blank pointed to the fact that consciousness must play a role in quantum mechanics. This is what he said. These are his words. Through the creation of quantum mechanics, the concept of consciousness came to the fore again. It is not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to consciousness. This created quite a row, but they couldn't ignore it because he's a Nobel Prize winner. But nonetheless, physicists still continue to try to get rid of the observer. They've been trying for 100 years. Now, let me just point out one really bizarre way they tried to get rid of the observer. It's called the many worlds interpretation. Now, this is an attempt to get rid of the collapse of the wave function altogether. Yeah. What it says is basically something like this. Now, okay, you have an electron and it's faced with two slits you can go through, right? So you can go through the right slit or the left slit. But what the many worlds interpretation says is that the electron actually goes through both slits. Yeah. What happens is that when it goes through the right slit, it's in one universe. When it goes through the left slit, it's in an alternate universe. So every time an electron encounters a situation where it can go either right or left, the universe splits into two. Yeah. And now you're thinking, wait, there are umpteen electrons in the world, right? And umpteen possibilities where it has to make a choice. So there must be umpteen parallel universes. Well, that's right. You know, 1 million universes, that's not enough. 1 trillion, still not enough. 1 trillion, still not enough. Yeah, because this process never ends. So they say there's an infinite number of parallel universes. You think about it, it's bonkers, isn't it? Yeah, I can imagine physicists, scientists 100 years from now will look back and say, look, these guys are crazy, you know? And on top of that, there's absolutely zero scientific evidence that there is such a thing as an alternate universe in this kind of fashion. There's no evidence at all. Yeah, the science fiction people love this, yeah, but they need to realize there's no scientific evidence for this. It all comes about because the physicists are trying to get rid of the observer. Because if there's no collapse of the wave function, then we don't need someone to collapse the wave function. We can get rid of the conscious mind from the theory of physics. But okay, let me tell you, even with such an extravagant ad hoc addition to the formulation, it still doesn't work. Okay. There are umpteen problems with this. All sorts of contradictions come up when you go into it deeply. But the physicists still talk about it. And that's why all the science fiction people pick it up. And but you'll notice that there isn't a single physicist that will go into this topic very deeply. They just touch on it, mention it briefly, and then they let it go. Because if you really delve into it, all sorts of contradictions will occur. So it actually doesn't work. Now, that raises a question. You must be thinking, well, surely not all scientists or all physicists are that crazy, you know? I mean, I'm painting them like they are fanatical believers in the materialistic world. They will accept nothing else. But surely not all scientists are like that. Yeah. Well, that's true. I mean, there are a lot of scientists who are quite Well, I hope there are a lot of them who are quite sensible, and they will say, look, this sounds like bonkers, right? Yeah. Why don't we just accept that the conscious mind plays a role in quantum mechanics? So what's going on? Now, actually, there is another problem, and that is what I touch on mainly in my paper. And it is this. It's the problem of a mind-matter duality. Now, this is a philosophical framework, and it started by Descartes, I think, many centuries ago. What it means is that our reality is made up of two components. There is the matter component, which is the table and chairs that we see that we knock into, and the walls and so on. And then there is the mind component. It means our thoughts, our experiences, our emotions. Yeah. So there is this mind-matter duality. Yeah. We all brought up like that. We all think, most of us think like that. Yeah. The problem is this. If we try to fit the scientific evidence from quantum mechanics into this philosophical framework of a mind-matter duality, it would lead to solipsism. And that means that we have to conclude that everything just occurs within the mind, that there is no actual external reality. And this, of course, is not acceptable to a lot of people, and certainly not acceptable to a lot of physicists, because then what are they doing with all these physics laws? If everything is occurring in the mind and there's no actual external reality. So that is why they have tried repeatedly to get rid of the observer from quantum physics for over a century. But we got to note that so far they have failed. They have come out repeatedly with methods of trying to get rid of it. And they always claim that, we have got rid of it. And then when people look at it closely, they say, no, you haven't. Yeah. But they're still trying, right? So the actual problem is trying to fit quantum mechanics into this framework of a mind-matter duality. Now, we got to know that even Eugene Wigner, the physicist that came up with the paper that declared that consciousness has to play a role, yeah, in his later life, he became very unhappy with it as well. And the problem he had with it was this idea of solipsism. It was not acceptable to him. So he wrote later on that he was hoping that there must be some new finding in physics that will somehow allow us to have an external reality. He never countered his original arguments. They were not refuted, but he just didn't like it anymore, because he feels that there should be an external reality. And all of us feel that too. Now, this is really interesting, because ironically, two of the original founders of quantum mechanics in the later part of their lives reached what may turn out to be actually the correct approach to the mystery of quantum physics. These two physicists were Wolfgang Pauli, he's one of the pioneers of quantum mechanics, and Werner Heisenberg himself, the guy that came up with the Copenhagen interpretation. And Heisenberg writes this. He says, the physicist Wolfgang Pauli once spoke of two limiting conceptions, both of which have been extraordinarily fruitful in the history of human thought, although no genuine reality corresponds to them. Okay, he says, at one extreme is the idea of an objective world. And that's pursuing its regular course in time and space, independent of any kind of observing subject. Well, this has been the guiding image of modern science. Yeah. At the other extreme is an idea of a subject mystically experiencing the unity of the world and no longer confronted by any object or any objective world. And this has been the guiding image of Asian mysticism. Yeah. And what he says is our thinking moves somewhere in the middle between these two limiting conceptions. We should maintain the tension resulting from these two positives. In other words, he's looking for a middle way between these two extremes. Now, I don't know what Asian mysticism Heisenberg was actually thinking about, but unfortunately, he obviously didn't know about one very important philosophical system called Madhyamika philosophy. That is also known as the middle way philosophy. Now, what is Madhyamika philosophy? First, this would actually fit in perfectly with what Heisenberg was looking for. Unfortunately, he didn't know it. Yeah. Now, this philosophy has been around for more than 1,000 years. Yeah, and it is actually forms the cornerstone of Tibetan Buddhism. But let me stress, it is not a belief system. It is actually a philosophically debated framework. And it's based on very rigorous philosophical and logical analysis. All right. And it has been around for more than 1,000 years. All right. Now, what we got to note is the formulation of quantum mechanics does not in any way suggest a mind-matter dichotomy. It also certainly doesn't suggest either materialism or solipsism. Quantum mechanics actually points to a middle way between these two extremes of materialism and solipsism, a realization that both Werner Heisenberg and Wolfgang Pauli eventually reached in the later part of their lives. That means actually that the formulation of quantum mechanics points to a philosophical viewpoint of Madhyamika philosophy, which is actually also known as the middle way philosophy. Yeah, and Madhyamika philosophy would allow us to include the role of consciousness in quantum physics without ending up in the extremes of either solipsism or materialism. Okay, but first let me state that Madhyamika philosophy has already been established even before quantum mechanics came into being. Yeah, so it would appear that it is the formulation of quantum mechanics that requires Madhyamika philosophy in order for it to make sense. Now, what exactly is Madhyamika philosophy? Now, there are many books written on it, and they are very deep and philosophical analysis. Yeah, but I'll just give you the key point in Madhyamika philosophy, and it can be summarized in this statement. It is that all things are empty of inherent existence because they are dependently arisen. Okay, firstly, I must stress that this is not a philosophy of nihilism. Okay, it doesn't say that everything is non-existent. It just says they lack inherent existence. It's a teaching of emptiness. And what it means is this: the very existence of any entity depends on causes and conditions. It depends on its parts, and it depends on the mind that apprehends it. Without this dependence on these other factors, the entity cannot exist at all. In other words, it cannot exist concretely and independently on its own right, free of these dependencies. There is no such inherently existing thing. That means the thing exists only because it depends on these other factors. All right. And the key point to note is that there is no mind-matter duality in Madhyamika philosophy. And also, we find that if you fit the quantum mechanics formulation, if you interpret it with Madhyamika philosophy, you don't have to change a single thing, and you don't have to add anything to the original quantum mechanics formulation. Everything falls into place. All right. Now, okay, well, that's more or less the end of that part, but I want to touch on one other thing that's very important with regards to spirituality, and it is this thing. Yeah, our mind is not derived purely from matter. Now, this is directly contradicting what most scientists feel. They think that the mind, the consciousness, is derived purely from matter. All right. Now, to begin with, there is no actual scientific evidence that consciousness arises from matter. What we do have is that the content of consciousness is linked in some way to the functioning of the physical brain. All right, that we know for a fact. Yeah, because if we have brain damage, it damages how we think. Yeah, but a link between two things does not necessarily imply that one created the other. This is very important. So we have evidence that there is a link, but we do not have evidence that consciousness arises from matter. Okay, now let me use an analogy. Yeah, if we think that consciousness derives from matter simply because there's a link between consciousness and the brain, it will be like a primitive man stumbling upon a modern television set. Now, okay, he sees the television set working. He's never encountered it before. But he notices that the picture on the monitor is linked to the control panel on the television. When he fiddles with the control panel, the picture changes. Yeah. It's the same way we notice our consciousness is affected if we change or damage our physical brain. However, if we insist that this is proof that consciousness must be derived from the physical brain, that would be akin to the primitive man insisting that the picture on the monitor must be derived from the physical parts of the control panel itself. Well, that's totally illogical and unscientific. That's the key point I'm trying to make. All right. Now, there's more evidence that mind is not derived purely from matter, and it comes from quantum mechanics. You see, what quantum mechanics is telling us is that the particles are actually dependently originated. In other words, like the electron, it doesn't really manifest until the observer makes the measurement. So it is dependently arisen, and it is dependent upon the measurement or observation by the conscious observer. Yeah, according to Heisenberg, he will say that physical particles only make the transition from the possible to the actual upon the act of measurement by the observer. So that means matter comes about because a conscious mind observes it. So that raises the question, so how can the reverse also be possible? If you're saying mind consciousness comes from matter, well, that's like going one full circle, isn't it? How can the physical particles be considered the cause of the mind of the observer when the mind of the observer is what causes it to manifest? Yeah, that would be like claiming that we can lift ourselves off the ground by pulling on our own bootstraps. It's a fundamental incompatibility. Therefore, it can be shown that mind and consciousness cannot be derived purely from matter, and it is quantum mechanics that tell us that this is impossible. Now, this is very important with regards to spirituality, because if everything we think and all our consciousness is dependent on the workings of the atoms in our brain, then why is there anything spiritual about it? Okay, but the scientific evidence actually points to the fact that our mind is not purely derived from matter. Okay. Now, let me just point out again that now, if we refuse to accept the scientific evidence from relativity and quantum mechanics that this is not a materialistic universe, it is like the prisoners of Plato's cave being given a glimpse of the outside of the cave, yet still refusing to accept the evidence, but instead returning back to staring at the shadows of the wall on the wall as though that is indeed the reality. So if we don't accept this evidence from relativity and quantum mechanics, we are back here. And we are deliberately refusing to accept the evidence. All right. Okay, I'm coming to the end of the talk. I just want to touch on why science and spirituality should not be separate. Okay, let me just read this. Because contemporary science neglects the sentient aspect of our reality, a very large number of people who are influenced by science tend to become very unspiritual. They believe what the scientists tell them, that the material particles determine everything. And so they believe that even how we think is determined by the action of the atoms in our brain. So there is no spirituality at all. And it is a tragedy. The world would be a much better place if the basic framework on which we base our actions is a spiritual one instead of the nuts and bolts paradigm of contemporary science. There will be much less wars, injustice, exploitation, and environmental problems. Now, there is unfortunately another negative consequence of this denial of what science is actually telling us. It gives us the wrong impression that the process of verification in spirituality would lead to the contemporary scientific view of reality, and that is that everything is the result of the materialistic workings of nature. This view is completely wrong. Unfortunately, some of the more spiritually inclined people who are misled in this way might end up simply relying on blind faith instead of trying to verify things. And blind faith, unfortunately, can sometimes lead to even bigger problems and conflicts. So, the process of verification of the spiritual truths is actually an essential part of the spiritual path. Each of us need to transform into a better and more compassionate person so that we can personally verify these truths for ourselves. So that is a very compelling argument why science and spirituality should not be separate. Okay, well, that's the end of the talk. Oh, maybe I should just finish with this. If any of you are interested in more details of what I've presented, you can go to the links here. Okay, you can just go to the website and you can find all these other articles there. There are other things there as well on Shakespeare and other things, but yeah, if you are interested, this gives the discussion of the topic in a lot more depth. All right, so thank you very much for listening to me. I think I've gone on for quite a long time. Yeah. So maybe I'll stop the share screen. Yep, and we can have a discussion.
Kenneth, wow, mind blowing. You know, even for some of us who are very basic knowledge in science, tend to get a glimmer of hope that there is some sort of continuity and there's some sort of attachment between the two and different functionalities of what we exist in. But it is a long subject matter, it's a deep subject matter, and firstly, I'd like to thank you on behalf of everyone for presenting the papers in a simplified way for us mortals to understand. So that's very much appreciated. Yeah, all your links actually have been shared by David with all the forums. So everyone's got those links on the WhatsApp chats and Facebook and everywhere. So that's anyone who needs wishes to carry on reading deeper and further, please use those links. Okay, first what I'll do, I will mute everyone, and then I will unmute everyone, which allows participants then to unmute themselves and ask their questions. Please raise your hands if you wish to. And I've seen we've got 11 viewers on YouTube as well. So there's quite an interesting conversation going on YouTube as well. Okay. David Felty is always one who brings a lot of light into our conversations. David, would you like to unmute and actually read your comments, because it's wonderful to have you actually recorded on the system.
There's so much wonderful in this, one hardly knows where to begin. I mentioned a couple of things there. Let me just say this one real quick, and that is, fortunately for us Freemasons, we have the Hermetic dictum, as above, so below, and as within, so without, and vice versa. Now that is, we must confess, more of an article of faith or a presupposition for any rational undertaking. Take your choice between those. And so that we certainly do have a tie in there. Let me try to focus on that in the following way. We do not know where an electron is because the electron does not yet know where it is, you said, or words of that effect. So let me ask a question. Is there a knowing function, consciousness, perhaps even self-awareness, reflective consciousness on the part of the electron? Or is this just a metaphor, a handy little bit of anthropocentrism?
Yeah, no, I don't think the electron is conscious. It's just a way of describing the thing.
Alfred North Whitehead, who together with Bertrand Russell wrote Principia Mathematica, did in his Process and Reality. He thought that the actual entities, as he called the ultimate subatomic, was a non-reductive monism of both mind and matter. So there
Yeah.
are those who maintain that with some philosophical and mathematical rigor. Just a thought.
Yeah, I think there are some people who think that, but I don't think
I'm not sure that I do, but I had to spend a lot of time learning about them. So
Yeah,
at
but
least
I
need to
think
give them
that's-
a look.
yeah, I think most people don't view the electrons as conscious beings. Yeah.
Well,
The-
just why? Since the metaphor fits so well, why do we get them off the hook for knowing what they're doing?
Well, they don't really have a choice, actually. Yeah. You see, in all those systems, like in the double slit experiment, whether they form an interference pattern or whether they don't depends really on one thing. It depends on whether the human conscious observer has the means to tell which slit it goes through. Once that is available, that means the information can be obtained, they have no choice but to decide. Okay, I shouldn't use the word decide. I mean, they have to determine which slit they went through. They really don't have a choice. You know, it depends purely on whether the human observer can tell which slit they went through. And once
Let me try to push it a little bit. Sounds to me like simply the psychology of a rebellious child. They can and they cannot rebel against it. They are and are not determined, but you can usually predict with a certain percentage of frequency when they're going to rebel and when they're not. So let me just tidy this up with another untidy comment about this, and that is, are we in effect asking, what is the universe like for us? Notice the square quotes. If we, square quotes, are not there. In other words, are we, again repeating, are we in effect asking, what is the universe like for us if we are not there? And that sounds to me like a classic case of Wittgensteinian nonsense.
Yeah, well, we have no access to such a universe. So actually, science cannot find out. They have no way of knowing what this is. Yeah, because
then as Edmund Husserl said, science as a rigorous science, therefore, that explain everything with nothing left over. And then he said, the dream is dreamed out. Do you agree?
No, not at all. What all science explores is actually the science of what we experience of the universe. If you think about it carefully,
Of course.
all the
What is
data is
everything?
observed data. Yeah, we don't have any unobserved data. Unobserved data, as far as science is concerned, means no data.
So that means that Immanuel Kant and George Berkeley and Husserl win. The idealists win, I guess. But let me see. There's Stephen Florian has said something I think is incredibly interesting. Let me toss the ball to him and go back into hiding.
Unfortunately, I cannot share the link with you right now because since I'm recording, the system doesn't let me to go into the article. But if you Google Lenny Howe, Danish physicist, you will find that she managed to slow down the speed of light to 38 miles per hour and eventually manipulate the speed of light. And this comes from sciennature.com blog. Now, I don't know in terms of veracity, but it sounds interesting. And on my other PC, there's quite an interesting article. It could be a first attempt. I don't know. I'm not regularly into science. I do follow quantum physics and I'm fascinated by it. I am a man of the arts myself, but I like to keep the balance between both because it balances me in more ways than one. All right. So that's what I posted for you there. Perhaps you might have heard of this.
Okay, just let me clarify. The speed of light that's constant in relativity is one that travels in a vacuum. Yeah, it is well known that inside different mediums, the speed of light changes, but the speed of light in a vacuum is always constant. So you can slow down the speed of light if you put it in different mediums.
I'm not aware in which conditions. I'm not aware, but definitely lab conditions now one has to see. But at least there's knowledge that attempts are being made as well. I mean, we don't.
No. The speed of light definitely slows down in different mediums. That's well known. So what Einstein is talking about is the speed of light in a vacuum. That is always constant. So I don't think there's any contradiction here.
But is it, when you say it slows down in different mediums, is it something similar to the Doppler effect in this sense?
Yeah, well, you see, in the medium, there's interaction with the particles because there are particles in the medium. So that slows down the process.
Let's talk outer space. What particles are there? Because we talk of ether, right?
Well, the ether is now considered a myth. Yeah, the empty space. Out there, it's just empty space. It's a vacuum. There's nothing there. Yeah, the speed of light in the vacuum is constant. Yeah, that's the foundation. That's the cornerstone of relativity. If that is found out to be wrong, then I think the whole thing will start to collapse. But I don't think that has happened.
But am I right in saying that the frequencies of lights coming towards our planet and being perceived visibly, be it a red light, a red frequency, as compared to a blue frequency, that means that one is going away from us and the other one is coming in our direction?
Yes. The frequency will change, but the speed of light still remains the same. Yeah, they're different things. Frequency is how many times it oscillates per second. Yeah, if it shifts towards the red, that means it suggests that the source is moving away.
Okay.
Yeah, but the speed stays the same.
It's mind-boggling, eh?
All right. Yeah. Okay.
Especially your first part of the lecture. I mean, there's lots of fertile land there to come up with new directions, I think, for which I congratulate you. I mean, the first part was very mind-challenging in terms of perception. And it can go very nicely on the second part as another scale. I mean, conceptually.
Okay.
PT scientists are so strict at times; they have to be, and they don't allow free thinking in a way, because the perception of the scientific result dictates that black on white. I mean,
I'm often puzzled why so many people are so against consciousness playing a role in science. I mean, I can understand that they don't like solipsism, but there are a lot of people, they don't even know about quantum mechanics, but they are very against it. They are almost frightened of anything spiritual. I've encountered a few people like that. They are, you can call them
are we really
fanatical.
ready to see what we can see? Are we ready to see what we can see? That's my statement on this.
Okay. Yeah, you can almost call them fanatical atheists. They're fanatical about it. They're more fanatical about it than the religious people.
Soviet physicists atheists coming to the conclusion that there must be somebody or something behind all this. I mean,
all right.
So they departed. Then this was in the 1980s. They departed from the atheist standpoint. Only they did not declare it. Perhaps out of pride.
I think some of them, some scientists, some of them, but most of them, I think, are materialistic. They don't like anything to do with spirituality. A lot of them. I mean, that's why, I attended the other talk on near-death experience. Even those doctors and, psychologists that encountered it, they dare not talk about it to the scientific community because they know it will be rejected. This is what I'm talking about. They seem frightened of it. I think, I'm sure most of you will have encountered people like that. They just don't want to know.
Yes.
I don't know why. Okay.
Perhaps it's their last frontier. I don't know.
No, they actually, I have a few people, a few friends, and even relatives. They seem positively frightened of spirituality. They're scared of it. I really don't know why.
On atomic proliferation, and remember the T-shirt. I mean, after and Einstein saying that if World War III is nuclear, then the next war will be with stones, and that is highly spiritual as well. You have the self-destructive attitude of approach.
Yeah, correct.
Thank you, Stephen.
Thank you.
Richard, you got your hand up. Please unmute yourself.
Yeah. Sorry. Thanks. Kenneth, can you hear me?
Yes.
Hi,
I'm
Kenneth.
here.
Thank you. I was very curious as to understand a few points you had mentioned. So you are saying that multiverses, according to you, don't exist.
Those parallel universes in that interpretation, to me, they don't exist. I'll put it this way: there's absolutely no scientific evidence for them. None at all. It all comes about as an attempt to get rid of the mind being the thing that collapses the wave function.
So the observer's paradox, when we do the experiment, the double slit experiment, we understand the way the particles move. We understand that if it is observed, it moves differently. If it is not observed, it moves differently. Correct?
Yeah.
And then we understand that there are no multiple universes. But when we do this experiment, we don't look at Schrodinger's cat effect, right? So the cat, even when we are there, is alive and is dead at the same time. So what are your points on that aspect?
Well, okay. Now, the important thing is actually this. We don't actually have to look to cause the collapse of the wave function. What has to happen is that the system has to be such that we have the ability to find out which slit the electron goes through. As long as the device is such that we can tell this, the electron has no choice but to decide which slit it goes through. That means that causes the collapse of the wave function. But it has to deal with whether the information can reach a conscious observer or not.
1 second, can I hold you at that moment, right? A conscious observer, when you speak of a conscious observer, does the observer has to be energy-wise present at the observation, or could an observer be even like me looking at you through a screen? I observe you. Do I change your atomic profile by observing you right now, even though that you are not absolutely in front of me, energy-wise?
Yeah, if you can tell what I'm doing, that means you're getting information. So yes, you will affect the thing because the information is able to reach you. If you put a scrambler in the screen and you can't see anything, okay, then you don't have this effect on me.
Would this also work?
It all depends on. Sorry.
Would this also work with animals?
Oh, okay. Well, that's a good question. To me,
still observing changes.
Yeah. So the question is, are animals conscious? Yeah. To me, they are. So if that's the case, animals can collapse the wave function. So the Schrodinger cat thing, can simply be explained by the cat causes the collapse of the wave function. Because if the cat is conscious, unless you argue that the cat is not a conscious being, then that's a different matter. But I believe they are conscious.
So one last point I wanted to bring up is that if we're looking at it from a multiverse perspective, which I mean, in a way, I do see your point. It's very clear why multiverses shouldn't exist in your context. But could it be possible that within the speed of time that we cannot control, that is standard, if it could be fluctuated, could there be multiple slices of those paradigms, like in the double slit experiment, within it, like a macro, microcosmo within that? It's very difficult to explain, obviously, this is the multiverse aspect. But could the observing paradox change on an X to Y scale on a different level that we don't observe?
You mean you're talking about different universes where the speed of light is different? Is that what you're talking about?
No,
I-
yeah,
I'm not too
possibly.
familiar
that
with
could also
this.
be possible, right? That could also be possible, right? I mean, it
Yeah.
doesn't have to just be the same in our universe. Reality could
Okay,
be that.
yeah, you have to realize that a lot of these physicists, they come up with a lot of speculations in their
Yeah, that's the
papers.
point.
They're just basically speculations, you know. There's most of them are just things they derive from fiddling around with the maths. Yeah. And they are not backed up by actual scientific experiments. So they'll come up with all sorts of funny theories and possibilities, but hardly, most of them are not backed up by any actual scientific experimental evidence. So this is what I'm saying.
Until someone comes along and says the king has no king has got no clothes.
Yeah, well, that's what happened with this superstring theory. You know, there were so many physicists were working on it, and then Richard Feynman, who's a Nobel laureate, comes along and says, "Hey, you know, yeah, there seems to be so many different versions of superstring theory. Yeah, it's like there are so many ways to skin the cat, but none of them are experimentally verified." He actually pointed this out.
But that
And
doesn't
of
mean they don't
course,
exist. I mean, just because
yeah,
you can't
well, it
scientifically
doesn't mean it
verify
doesn't
something
exist,
doesn't
but
mean you can't say it's not there, right? You have to take both sides of that argument.
you're right. But let me make this clear. It is not science until it is scientifically proven, right? As long as it's not scientifically demonstrated or proven, they just should be considered as speculations by scientists. It is not science. And this is a common mistake a lot of people make, because all the scientists come up with all sorts of funny hypotheses regarding how the consciousness comes about, but none of them are backed with actual scientific evidence. So all that amounts to are simply speculations by scientists. That's not science. You got to make that distinction. Otherwise, you can mislead a lot of people.
But say, for example, the pharmaceutical companies, for example, right? They are scientists, right? They create drugs. They are doing it like scientifically, as you just mentioned. But none of them got their science from doing science. It was from extraction and old literature, old books, old knowledge, ancient knowledge, that they derived these sort of principles, obviously from hands-on execution, checking herbs. Some people died from some berries, some people didn't. They figured it out, then they extracted it, and then the science came into it. So the science of a scientist has only come through speculation. I mean, there would not be science unless people speculated that, okay, I cut the stone like this, will it roll now? You know, and it rolled, okay.
No,
So,
I agree with that. I mean, initially the scientists were speculating. That's how people win Nobel Prize. they do it largely like in quantum physics. It's done by trial and error. They don't really understand why the maths work, so they're speculating, and sometimes they hit the jackpot, and then it is shown to work experimentally. But until it can be shown to work experimentally and it corresponds to the experiment, it has to remain speculation. You have to
like
distinguish
mathematics.
between.
Sometimes people can come up with an answer, but they don't know how to get to it. Like they know the answer is correct. Everything points to that answer, but nobody can calculate that answer the same way. It happens in science. It's not an uncommon thing.
Yeah.
So
Okay,
that's completely opposite too. That's like nature is telling you that this is a fact, and now you have to speculate your way to figure out why that fact is actually functional.
That's trial and error. You see, there are some physicists that insist that they understand quantum mechanics. Okay, now don't be fooled by that. They don't understand it at all. What they can do is they know how to compute the results. Yeah, so and they insist that because they can compute the results, they understand it. But let me tell you, that's like saying, look, I know how a car works because I can drive one. You see the difference? Just because you can drive one doesn't mean you know how it works. Well, that's the situation with a lot of the physicists. They say, well, we understand quantum mechanics. What they're saying is they can derive the results, but they don't really know why it works. If they knew why it works, we wouldn't have like umpteen interpretations of the quantum mechanics formulation, would we?
And there's so many different string theories and all of them trying to be combined, and everybody disproving everyone else. And 30 roads to Rome. I get it. It makes sense. I know. And it's a lot of speculation anyway. Thank you, Kenneth. A lovely chat and a lovely lecture. Take care.
Yeah,
Good
my
night.
pleasure.
Just something that occurred to me while Richard mentioned multi-universes. Would it be more appropriate to think of multi-dimensions rather than universes? I'm thinking simply like a cake. Not too many cakes on the table, one cake, but many layers. So you have multi-dimension, multi-flavors in that one cake, which react differently in terms of how it interacts with our taste buds.
Well, of course, it is possible there are other worlds or other, planes of existence that we have no access to. Yeah, that cannot be ruled out. But what I'm talking about mainly is the scientists' view that there is an infinite number of parallel universes, and they claim that this is science. Well, it's not, because there's no scientific evidence for it. So that's the difference. I'm not ruling out the possibility that there are other planes of existence.
Well,
not at all.
What you're basically trying to say is that unless you can prove it, even theoretically, yeah, it's just a conversation. You can write as much about it as you wish to.
What I'm trying to point out mainly is that when scientists make all these speculations, there is a tendency for them to call it science, but it's not. Yeah, and we got to recognize that they're just speculations by scientists. That's not science. That's a difference, and we need to be aware of this. Otherwise, they can easily mislead all of us. They're calling things science, which are merely speculations by scientists.
You mean because they've run out of tools of measurement, they cannot measure?
Yeah.
Okay.
Knowledge
for knowledge.
Yeah, there are a lot of things that they cannot measure. The most important one is they have no instrument that can measure consciousness, none whatsoever. Yeah. So that is why I say the scientists know next to nothing about consciousness, because they have no measurement equipment for consciousness, which means they have no data on consciousness, and no data means they have no theory based on the data. So ultimately, they really know next to nothing about consciousness, because their scientific equipment cannot probe it.
Meanwhile, we're playing with artificial intelligence, not knowing where we will end up.
Well, that's true. But artificial intelligence and consciousness are two different things, actually.
It could be a parallel universe, huh?
Sorry, Kenneth, I was just going to say, so does that mean that these individual particles you speak about have got some sort of conscience in themselves? Because when you were doing your presentation and the slips where you mentioned the word, we're being observed, so let's
it's a bit tongue-in-cheek, actually.
You can always say that you need a conscious thinking ability to be able to change what you're supposed to do, and you decide, no, I'm not going to do it this way, I'm going to do it that way. So where does that sense in science?
No, actually, maybe I've been misleading people by putting it that way. It's just easier to present it that way, I really don't think...
I'm just trying to catch you out.
I don't think electrons actually are conscious. Yeah, because like I say, they really don't have a choice whether they form an interference pattern or not. It depends on whether the human conscious observer has access to that information or not. That thing determines how they behave. They cannot choose to behave otherwise.
So we determine by our thinking what we think they are thinking. And
it's not just our thinking. It's whether we can we have the means to determine which slip they went through. If we have that means, they will have to sort of now, how am I going to put it? I'll have to say they have to decide where they are. I don't know how else to put it.
Kenneth, you did say the cat is the observer. When you said in Schrodinger's cat, the cat is the observer of himself observing.
Yeah.
At one point. So what you're talking about, the atom is also the observer of itself.
No.
You don't believe that? Okay.
No, the cat, I believe, is conscious. The atom is not. Yeah.
But the cat is made up of atoms.
We can always ask
Well,
Richard's
well-
cat in his background if it can think for itself.
Well, that's the whole basis of this von Neumann chain, you know. That's what he's saying, you know. You put a device there, and the device, like a microscope, is looking at the electron, but the device is not conscious. So it becomes entangled with it, and it just forms a bigger quantum wave function. It becomes a bigger probability wave. That's all.
But that's like
There's still
that
no
massive
collapse of
brain
the
that
wave function.
controls the universe, right? Because once quantum entanglement occurs, then all the energy and messages come into one, and it becomes a singular being called the, what was that brain? The high, I've forgotten the name of it. A brain in the universe that has its own consciousness. I've forgotten the name. But is that possible in your mind? Do you believe that the culmination of all these quantum
Well, I
entanglements
mean,
could
you're
create a
asking,
superconsciousness?
is there a conscious God, right?
Yeah.
Well, I think you all can
Scientifically.
answer it for yourselves.
Scientifically, I'm asking, not
Scientifically, I
speculatively.
don't think they have evidence of it. It's speculation. It may be, yeah.
But quantum
We don't-
entanglement in itself becomes conscious. That means it becomes God, no? In a way.
No, but Richard, the scientific way of thinking is God exists, but we don't want to talk about him at the moment because we have other theories to prove. David Felty, you got your hand up for a while. Hello, David.
Okay, let me figure out how to do that. Just one more question, and it kind of fits real good right at this moment. And that is, there are a lot of philosophers, even if they do not believe in the existence of a God, who like to do thought experiments based upon the God's eye point of view. And so I want to ask this: if we cannot perceive any change in the speed of light because our brains are also electromagnetic, does this mean, one, that all the peculiarities of Einsteinian relativism would disappear from the God's eye point of view? Or two, then we might follow up and ask, so what would the universe look like from the God's eye point of view?
Okay, interesting way to put a question. Well, we don't know God's eye point of view. What we do know, or in fact, God would also know this. I mean, assuming you believe in God, that how the humans experience their so-called time and space is dependent on electromagnetic transmission and the speed of light. Now, there is this phenomenon in relativity called the twin paradox. Where you have one twin on Earth and one twin on a spaceship, and the one in the spaceship travels very fast, on a journey, and he comes back after 2 years. Okay, 2 years according to him. He gets out of the spaceship and he looks at his fellow twin on the Earth, and the guy has aged 50 years. And he'll say, "Hey, I only went away for 2 years. What caused you to age so fast?" And the twin on the Earth will say, "What nonsense are you talking about? I've been waiting here for 50 years for you to come back. And how is it that you are so young?" So now this has actually been experimentally found to be correct. Of course, they haven't done it with humans because we don't have rockets that travel that fast, but they've done it with atomic clocks. And it does seem to hold. So
yes, they did. NASA did. There are two twins astronauts. One of them is currently a U.S. senator from the state of Arizona. He and his brother, one went up in space, one stayed home. And they figured after a year in space, they figured out something like they were 6 seconds different in their age or some thing.
How did they measure their age to that accuracy?
But Kenneth, the other thing that occurs to me while having this conversation, and you mentioned the word observer a number of times. Now, the human brain at its maximum functionality is only probably 5% used, 10% used, with the rest being dormant. Now, can we really say that what is observed is actually what exists, or is it just observing a very narrow element of what it perceives to be, what it sees, or what the eyes see and the brain observes?
Yeah, I think by observer, what I'm talking about is it's a conscious a conscious realization of things, you know. It's not just like you can say, you know, a microscope observes this, but it actually doesn't, because it's not conscious. I'm talking about a conscious component in being involved in the observer.
Okay. So it's not a facility or the faculty to be able to analyze, but it's just being there to
Yeah.
observe.
Being conscious.
Conscious, yeah.
Yeah.
Because,
A lot of this,
whichever bit of the brain is conscious observation rather than actually physically using the capacity of the whole brain.
well, that comes back to the question: this is consciousness caused purely by matter? Well, I don't think so. So the brain, to me, well, there is a link with thinking and consciousness, but it doesn't cause it. So there's something more than just the material part of the brain. Well, it's like the television set, you know. It's more than just the control panel, isn't it?
Yeah,
I mean, there's the electricity, the
other
electrode,
components.
the waves, and all those things. There's a lot of things other than just the mechanical part of the television set that's involved.
But you mentioned all these others. One of the things that fascinates, or I always think about, is sound. Where does sound come into all this?
Where does what? Sorry?
Sound. This, you know,
sound.
The echo, yeah.
Ah.
The sound has its own properties and its own.
Yeah. Okay. Yeah. I think you're talking about a thing called qualia, right? The experience of things like sound, color, and things like that.
Yes.
Yeah. Well, that is actually has to do with consciousness, because you know even things like color, you know, the universe out there, sort of thing. Yeah. There's no such thing as color. Because we see different colors. It's really it's caused by different frequencies of the light rays. Yeah, frequencies is just a number of oscillations per second. What has that got to do with color? So yeah, it has something to do with the brain presenting this sort of thing to us, and that we experience it as color. We actually have to experience it. Otherwise, there's no such thing as color.
Yes.
All we have are different frequencies.
So all these things are how what we see is a perception of what we think color is, really, rather than what color actually is. But as you said, they're all frequencies and vibrations.
Yeah, well, in the physical
because
world,
the color itself could, you know, red color could be a different red to me. The same red would be a different red to you.
Yes, that's right. Yeah, what I'm seeing as blue may not be what you're seeing, but you still call it blue because your whole life you've been taught that is blue. Yeah, well, that's true. We don't really know. Now, there was this very interesting paper called "What Is It Like to Be a Bat?" This is a very important philosophical paper arguing about consciousness, you know, because bats have this sensory apparatus that does echolocation, right? We don't have this, you know. So what actually does the bat sense when he does echolocation? Now, we have absolutely no idea. You get the point? And no amount of scientific equipment will tell us that. So that was the key point that I think the philosopher, I can't remember his name now, was trying to make, is that there is something more than just the scientific nuts and bolts thing. Because no matter how much scientific equipment we have, we will never find out what it's like to be a bat experiencing echolocation.
I mean, it's like a scientific equipment going back 100 years, and today's equipment, you know, the antiquated stuff, though it measured time or it measured distance, but now is that same equipment has been developed so much that it has changed our perspective of those things with the new measurements. And in 100 years' time, what we think today will have changed because there'll be other equipment that will completely change the way things are observed or measured or written about. David, you got your hand up again. Please carry on. Don't raise your hand. Just dive in.
Well, I'm kind of hesitant to do that because I often do not show great wisdom when I do.
No. Your wisdom is
but-
worth it.
But I'm familiar with the, I don't remember the author either, but I'm familiar with the What Is It Like to Be a Bat article. I just don't remember who wrote it. But my philosophical mentor, Richard Rorty, had a quick reply to it. He did not like such approaches. And he simply said, well, whatever it is like to be a bat, it isn't much.
Whether it's much or not is irrelevant. You don't know what it's like. Yeah.
Well, that's why he said whatever it may be to be like a bat. There's being like something, of course, is a way of trying to stretch analogical, not anagogical, but analogical reasoning to its fullest extent. And he thought analogies were analogies because eventually they always broke down. And what it is like to be a bat, it either broke down or there wasn't anything much there to worry about breaking down about. That was basically what I was trying to say.
The article is by Thomas Nagel.
Yeah, okay.
Nagel, yes.
I think that's
Nagel.
him. Yep.
Yes.
Okay. That paper is actually very important because it actually gave rise to the definition of consciousness in the philosophy of mind. Yeah. So consciousness in philosophy of mind is described as something it is like to be that thing. If there is something it is like to be that thing, then that thing is conscious. Like you can say, what is it like to be a cat? That sort of makes sense. Yeah. You can't say, what is it like to be a table? Well, that doesn't make sense, right? So that is the thing that distinguishes between a conscious thing and one that doesn't have consciousness. You can't ask, oh, what is it like to be a chair? Well, I mean, what are you talking about? You know, it doesn't make sense at all.
I've never been convinced that animism has been refuted, so I'll hold out even for a table. But it's interesting. That's why philosophy of mind now has shifted. When it talks about theory of mind, it's no longer talking about how I can prove that something else has a mind just like I have, but only seeks to determine whether that something else thinks that it has a theory about the mind of others. They remove it. They kind of go into the passive, to the passive mode, saying that I cannot prove you've got a mind, but I can examine your behavior to determine whether or not you think that you know whether I have a mind.
Yeah, but you know what I really would like the people to take a new direction in is that rather than just stick to scientific equipment and materialistic things of exploring the universe, why don't we use the mind to explore the universe? This is an aspect that most scientists simply reject, and I think that is a real tragedy because you can use the mind to explore the universe, and you're going to ask all those meditation experts, and they'll tell you, yes, it's true.
I was just going to say something very simple. That we tend to be scientists tend to have this idea how to disprove the existence of God, rather than saying, hey, he exists, let him exist, we can exist as well at the same time, and let's all be friends. But I was just going to say something about the bat, and that if you want to sort of find out what a life of a bat is, maybe ask those who spend their day sleeping and nights partying. They may be able to tell you the experience of the breakdown of day and night.
Yeah, but no, they still wouldn't know, because you see, one interesting thing about echolocation, they can detect the position of things, but echolocation can give information about the speed of, say, the insect the bat is chasing. They actually have direct experience of the speed. Now, how do you experience? We have no idea how the bat experiences this. That's the point that I think Thomas Nagel was trying to make. No matter how much scientific equipment can explore this, we will not find out how the bat experiences this. That's something extra.
Kenneth, we've been here just over just coming under 2.5 hours. You know, we don't. I know you're in Singapore and your time is a different clock. So please let us know when you have if you wish to, you know, finish the discussion or if you've got time to carry on. But obviously, one of the things that I'd like to do is, I'm sure David will agree that we'd like to invite you again with something, you know, another paper on another of these scientific type of ideas and consciousness and God and all the other theories put into a nice melting pot. So please, you know, be free. But we can carry on if you have time. Otherwise, we are happy to conclude and give you another opportunity again to come back and thrill us with your ideas.
Yeah, I'm quite okay actually. Either way, I think but I think well, if anyone has any really important question to ask,
well, my brain is ticking. How does one explain human intuition? And not just at the level of self-preservation instinct, sort of. How does one explain extrasensory perception? How does one explain astral projection or voluntary astral projection? Sorry. And experiments have been done in Scotland under hypnosis. Somebody goes out of his body and interrupts an infrared beam, and the alarm goes on. All right. I mean, there is will and there is thought. Cogito ergo sum. I think, therefore I am, which had evolved even further. Cogito sum. I think I am, to that level. So I think we are quite in control of our commands as human beings, in as much as to destroy ourselves as well. Unfortunately,
double-edged sword.
Yes.
Yeah, but these are some of the things that scientists can maybe they can tell that it does occur with their equipment, but they really can't explore it, you know, because it deals with the sentient aspect, and that is why I think that the people who are interested in exploring the universe should learn to make use of the mind to explore the universe as well as the scientific equipment. Why restrict ourselves? Because otherwise we are like the prisoners in Plato's cave, right? We are not even prepared to expand our horizons. And I think we should.
Also, Vivekananda also sort of elaborated and so had another analogy about the frog living in the well, doesn't know that there's a world that exists outside the well until it meets a frog from outside the well. And because this frog from outside the well is talking about all this world outside, all the frogs in the well want to just pick him up and throw him out because he's coming up with new ideas, something that they can't understand or they can't contemplate.
Yeah, correct. Yeah. This is the thing that sometimes I puzzle over. Why some people are so afraid of spiritual matters. I don't know.
Because we are not ready for what we see, probably. We're not ready for what we see.
Yeah.
And that's
why are they frightened of it?
A different sense of time. But it could be spiritual time, I mean, in order to strengthen our fiber as human beings.
Maybe Kenneth, next time, maybe you could talk about spirituality and religion from a scientist's point of view.
Well, you know,
without the science, but whenever you're ready with a paper or a presentation, please let us know.
Yeah, have you seen my paper, The Spiritual Path?
Yes,
that is really quite an eye-opener. It's on my website.
Yes.
It shows the synchronicity between the Kabbalah tree of life, the tarot.
I was reading it this afternoon.
Okay.
That
one is interesting.
Maybe we could have a nice conversation if you want to present that in the future.
Yeah, okay, I'll think about that. Yeah, that one would be very interesting, I think.
Yes, I think so. Well, having read it, I know it's interesting. So.
Yeah.
Sorry, go ahead.
Okay, no. I mean, yeah. Is there anyone want to ask anything?
Anyone else? Any comments, questions? Any final comments? Any thank yous? Anything? Caleb, finally you raise your hand. Please go ahead. Caleb.
Hey, Kenneth, how's it going?
Yeah. Okay. Good.
I'm just curious if you've ever visited Namgyal Monastery in New York.
Where is that?
It's in Ithaca, New York.
Oh, in New York. No. I haven't been to New York actually.
I'm just curious if you'd seen that. And then if you have any Tibetan Buddhist text or particular meditations or lineages that you studied that helped you better understand what you're doing. And then the second question was if you've contemplated Taoism or the Tao and this middle way or centrist Tibetan Buddhist philosophy.
Well, I'm mainly a follower of Tibetan Buddhism, actually. So I have a lot of Buddhist texts, Tibetan Buddhist texts. Yeah, it does influence how I think a lot of things. In fact, the Madhyamika philosophy that I mentioned in the talk, that comes from, that's largely, it's a very important part of Tibetan Buddhism, actually. It forms the cornerstone of Tibetan Buddhism, this teaching on emptiness. Now, you may be wondering, what has this philosophical system got to do with a spiritual discipline? Yeah, what they're trying to do in Tibetan Buddhism, okay, the central idea is that all things are empty of inherent existence because they're dependently arisen. The main aim why the Tibetan Buddhists make use of this is they're trying to apply this to the I, the self. And it is used as a way to counter all our self-centered kind of attitudes. So if you come to realize that the I, the most important thing to most people, actually doesn't inherently exist, it breaks down a lot of the barriers between the self and others, and it transforms your whole personality. And that is what they're aiming at. And it becomes very important then, because if you can really come to that realization, not just an intellectual understanding, but to actually realize it so that it changes your life. That's what they're aiming for.
So you're not othering yourself or drawing distinctions. You're seeing that there's a kind of a connective aspect to things. Because I suppose like if you were to do a deep dive into those ideas of non-dualism or non-attachment or non-being, it's very interesting, to just contemplate that kind of selflessness, if you will. And yet there is the I amness that Stefan was doing. So it's like you don't want to over or under perform. Like I suppose it would be good to just keep an equilibrium or balance in your own life and interactions. So it's fascinating,
Yeah. Well, some people think that if you lose the sense of an I, you can't function. That's not true at all. In fact, you become a really more compassionate person, because then you do not distinguish between the self and others, and you become an all-caring personality. That's the ideal. Yeah. But you definitely can function.
Well, it seems interesting that there's sort of this will to want to create a proof or evidence, so there's at least, from certain perspectives, there's an idea of being omniscient, omnipotent, omnipresent. And then there's another aspect of not being able to articulate that to other people, this ineffable, it's inexpressible, and there's no concrete proof. So the spiritual realization is not even necessarily one that can be shared. It's individual and yet connected. We're almost like interdependent, dependent, codependent,
Well, you see, that is mainly a limitation of words. I think this is something that I think a lot of people in the West don't realize, but people in the East tend to realize this very early, that words have very severe limitations. So being ineffable simply means you can't put it in words. It doesn't mean the experience is not real. It is very real, but I can't tell it to you if you haven't experienced it, because words only function by a shared kind of experience. Like, I mean, we have a fruit here in Singapore called a durian, I can't tell you what it tastes like because you've never tasted one. Yeah. It's something like that, So if you had the experience of tasting one, then I'll say, well, it tastes like durian and you'll understand. But if you've never experienced it, well, how am I going to tell it to you in words? That makes it ineffable, but that doesn't mean the taste of a durian is not there. It is there. I can assure you.
I've tasted it, but you've got to eat it something like this.
yeah, it's very strong. But if you've never tasted it, it's ineffable, isn't it? I can't tell you what it tastes like.
You can't describe the taste. You can describe the physical fruit itself, but not the taste itself.
Yeah. So a lot of these.
How does this coincide then with this idea of emptiness of the emptiness? Philosophically, there's this idea of emptiness of emptiness.
Absence of interface, probably. We need interfaces in order to communicate. Perhaps.
Yeah, they're talking about the concept of emptiness. You see, the concept of emptiness is also dependently arisen. I mean, someone imputes this concept. So it is empty of inherent existence. That means existing on its own right by itself without all these other dependencies. Well, actually, if you think about it, it depends on somebody talking about it. Otherwise, there's no such thing. So in that sense, it doesn't inherently exist. So it's empty of inherent existence also. Of course, that's not saying that everything is totally non-existent. That is a bad mistake, Madhyamika philosophy is not about nihilism. I have to keep emphasizing that in case people get the wrong impression.
But there's empty, we talk about emptiness out there in the sky. We look at the dark sky, we say it's emptiness, but we're only observing what we see. We don't know what's out there.
It seems there's inherently a potential with that. You have space, you have a place value, a possibility wrapped in there.
Yeah. That's why I say it doesn't mean there's nothing out there. It's not nihilism. There is this appearance and functionality. But if you try to look for the object, let's say you try to look for the eye, you can't find it. Even Shakespeare, I think, realizes that. If you've read Romeo and Juliet, Juliet says, well, what is Romeo? It's not a hand, it's not a foot, it's not his hair, you can't find him anywhere in any part of his body. So in that sense, he doesn't inherently exist because Romeo depends on his parts. And the significant thing is all those parts are not Romeo. So none of those parts can be called Romeo.
Can I jump in?
In a sense, it's an imputed entity, isn't it?
Can I jump in there?
Yeah, sure.
This is an issue that I'm dealing a lot with right now. I think a big mistake that we make is using words that are not common in the West. Like when you talk about an inherent existence, most Westerners don't really grasp what you mean. So it would be better to say, when someone talks about this kind of stuff, living for eternity, in essence, being in a Western mind, being the same thing as the Almighty God, because the only way you can have this inherent existence is you live forever. Number one. Number two, you would have to be everywhere. And in order to not be causal, everything would have to be a part of you. Then in reality, then there's no such thing really as you, because you would be everything. So that's all a big mistake. And that's pretty much why the Buddha tried getting away from that, saying that, okay, there is this individuality, but if you get caught up in this individuality, you're going to be trapped in samsara. You have to accept the fact that your life is temporal and that the things around you affect your life.
Yeah, I think it's
and the idea of change. That's the other thing. This, because this thing about an inherent existence meant that there was also no change, which also we know change is all around us. In the West, whenever we talk about a self, we consider change to be self-evident.
Yeah.
Already,
Actually,
you'd be talking about two different things then.
yeah, no, actually, this realization of emptiness, it goes a lot deeper than it. What you mentioned is part of it, but it's a lot deeper than that, because if you really get to realize this emptiness of the self, the I, okay, yeah, it actually it transforms your whole perspective. Yeah, when you get this, you actually enter. It's almost like a different state of being. Yeah. And it's like a mystical experience, yeah. And so it's a lot deeper than that. And I've had glimpses of this. And now the thing is this: I've noticed that it's a very blissful state, and it's a different state of being. And every time you get this sense of an inherently existing I coming into your mind, that state of mind disappears. It's gone. Yeah, it happens. It's happened to me so many times that I know now that when this state of mind goes, yeah, I have to hunt for this. I do witch hunt. Where does this inherent state of sense of self?
Yeah, but this goes back to what I'm saying. You know, for most Westerners, they never see themselves that way. You know, we always see ourselves as changing. And even if we're not religious, then we see the impermanence of our life. That's just the way it is.
Mm-hmm.
You know, so there is sort of this different philosophy in the sense that in the West, there wasn't really this quest for immortality. And if there were people who believed in immortality, it was always immortality under God. So then God had control over their mortality. And you never placed yourself in a position to where you considered yourself above God, in the sense that you ultimately controlled everything. You know, even your sense of self or yourself was still controlled by God. So when talking to Westerners, this idea of emptiness, I think really gets confusing, when really what you're trying to tell us is to stop being so selfish. Stop putting yourself first.
Yeah, yeah. Well, that is one of the effects, yeah. But what it does is it's hitting at the very source of this selfishness. That's the important thing. If you can attack this source of the selfishness and get rid of it.
Approach is, if you look at it that way, most people who are greedy, they're greedy because of the idea of impermanence. They only have so much time to get it, so they want it here and now, and they want all they can get.
All right. Yeah.
It's impermanence.
It may take more than a lifetime to get there.
See, already you're searching for eternity. We don't have eternity. We have right now. This is how we look at it in the West.
Yeah, but you know, it's very interesting you say eternity, but are we not eternal anywhere? We are just a composition of everything that exists in the universe.
And in the West,
we are not, you know, we're not, you know, everything that is us, including maybe what we call the spirit or the soul, exists within the universe, and all that's happened by some sort of miracle, some sort of science, whatever you want to call it. All these different elements are combined to create a human. And when we pass, it uncombines us, you know, breaks us back into our components, and we go back into where. So really, you know, this sort of whole concept of immortality, I think immortality in the sense that you're talking is like, oh, I want to live forever in this body or a next body. I should remember what I've done in this time, and I should accumulate that and take it. If I have wealth, I want to be wealthy. But you know, for me, from coming from a Hindu background, it's much more sort of easier to comprehend mortality and immortality. It's very much similar to the Buddhist of concepts, really. You know, that We are transient. We're not here as a, we just go back into our own parts and end up being part of our original material.
Yeah, well, the Tibetan Buddhists actually accept that there is a stream of consciousness and that this continues on. But they say that you can't find the I in there either.
Yes.
But there is this continuity.
But it's a pure consciousness that survives, that continues, because it leaves the I behind, and the pure consciousness leaves us and carries on, whereas the I is left with the physical self, because I is me, my physical personality, not that entity that rests within me, which will be the soul, spirit, however you want to define it. So I probably contaminate that purity through my physical presentation rather than anything else.
I guess the point to all that is, from a Western standpoint, is the I, this thing that we call I, is an accumulation of things that, yes, gives us the sense of order and the sense of who we are. But the bottom line is everything exists that way. So that's just the nature of reality. That's just the nature of the reality around us.
But
everything is composed the same way, even the pencil I'm holding.
But if you take I in isolation, it's a different thing. But if you take I in the context of everything else, I can mean so many things. I am a good person. I will be able to do that. I can do that. I will be able to help you. That I put in a proper context changes the whole concept of how we think as human beings.
Exactly. So that's why I say, when you look at it from a Western standpoint, you accept the fact that I is dynamic. You accept the fact, you're born with this kind of thinking already, that I am this way today and tomorrow I'm a totally different person. These notions are what we're working from. So there needs to be a restructuring of some of the Buddhist teachings, for Westerners, is actually what I'm getting at. Because
I think all the Eastern philosophies need that, because Western culture.
That's true, but it's easier to start with Buddhism. Hinduism, number 2, in general.
I mean, the practice of yoga is a commercial exercise where you pay a certain amount of money, you're going to sweat it out for an hour, and that's it. All the elements of your spirituality and your understanding of your own physical self doesn't exist. That's not relevant.
Yeah, that's true. Well, yoga in the West is not the same as yoga that it was intended to be.
Yeah. So,
Charles, it works the same way in Christian faith. Do you really need to go to church every day in order to be a spiritual person?
Yeah.
Remember, you carry a sacred spirit. You've been entrusted with a sacred spirit, a spark from the light. The rest is minute detail.
The Bible does teach that, but you do have to be careful, because the truth of the matter is the church also, as an institution, has written the scriptures.
In the West, we compartmentalize.
Sorry, gentlemen, can I just interrupt for a second? Well, taking consideration of the time with Kenneth, it's 3 o'clock, nearly coming at 3 o'clock in the morning.
Yeah, it's getting close to 3 a.m.
Yeah, so I think, if you want to close and if you want to carry on the conversation, it's
Kenneth,
fine.
you've set our brains on fire,
huh? We're gonna allow Kenneth to maybe say anything he wants to say before we close the formal part, and then we can carry on the conversation.
Yeah, yeah, sure. It's been a pleasure to be here, but yeah, and I'm glad that you found this very interesting. It is this science and spirituality thing is something that's very important to me. I've spent years on it, so I'm very glad to be able to talk to all of you. Thank you for the opportunity.
And we already got a slot for you whenever you wish to come back with another presentation. So
on the spiritual path. I mean.
Yes,
Yeah.
that would be
Can I
wonderful.
get
All right,
Sure.
I'll have to think about it. That one is going to be, yeah, it's a
Whenever,
lot.
anytime. I mean, we've been here for coming on to 2.5 years, thanks to David and his hard work. I'm sure we're going to be here for a few more years. So you got time on your
Okay,
side.
all right. Yeah. Okay.
But thank you very much formally from all of us, and I think it's a
Yes.
subject
Okay.
that has
Excuse me.
I think.
Before we part, can I get your email address? I'm going to be in Singapore probably next month or the month after next. No, I take that back. It'll be
Yeah.
Christmas.
I'll tell you. Okay, I tell you what. You can go to my website, and there
Yeah.
is.
I'll be
there is a
spending
part-
3
you click
months
on-
there.
You click on contact the author,
Okay.
and you're Charles DeCosta, so I'll remember.
Yeah.
Yeah. Okay. Yeah. You can
That's
you can
just
click on that.
You could give us the
Contact the
website. Someone
author.
said you got to type it in the chat.
Oh, okay. Actually, it's.
actually,
it's
I
actually.
think what we'll do is David has the details of David Felty, and we can forward him all the three on your website plus your presentation.
Yeah. You
Would
go
that
to
be
my
useful,
website.
David? Yeah.
And you click on contact the author. That's the email there. Then you can get to me.
Yeah, we'll
Okay.
we'll get it sorted. David Felty, we'll sort that out for you. I think David C will forward you the details. the
I'm
links
not
and-
really sure. I don't have it.
Well, David
You
will
think-
will
You
probably
think I have
email.
his email address? I do not.
Well, he'll forward you the email with all the detail, David, if it's there. But we'll sort something out for you.
You got the wrong David. Shouldn't David C do that rather than me? I'm
No,
trying to keep light.
Yes.
Are you on the WhatsApp?
I just-
Because David sent those links to the WhatsApp. You just click on the link and you'll go to my website. And
I just shared the link.
there's one
The
section
link,
there
the link
that
is in the chat now.
Yeah.
Caleb has just put the link in the chat.
all right, yeah. If you go there, you'll find there's on my website there's one section that says contact the author, and my email is there. That's probably the easiest way to get it. Yeah.
Thank you.
Thanks.
Caleb.
That's great. That's great.
Yeah,
In the
okay.
chat there. Thank you.
Well, yep. Good night then. Yeah.
God
I
bless.
think
Good night. Thank you for your time.
time I
and
hit the
wish you a good week
Zach.
ahead. Take care.
Yeah. All right. Yep. Bye.
Bye-bye.
Bye-bye now. And I'm sorry I got there so late.
That's fine. Yeah.
Thank you very much.
Okay, so anyone wants to download the chat and keep a copy of the chat, please do it now before we sort of close the session. Very interesting session. I thought, we were. I was
actually feel
amazed
kind
at
of
the amount of.
silly because I'm having a hard time finding where. Oh, that's right. On phones, you can't download the chat. I remember now.
No, you can only download on a laptop.
Computer. Yeah, that's why I couldn't find it. All right. Thanks very much.
No problem. So if everyone is okay with that, I'll close the session and we look forward to seeing you again whenever, I think maybe Sunday or next week, whenever David has got the next planned presentation. But it's been interesting and good to see familiar faces and good comments and conversation. We'll all go to bed. We are going to bed with a mind still bubbling over.
Thank you very much, Brother Hasu. Most interesting. Thank you.
Thank you. Thank you. And we'll see you soon. So be happy, be safe, and tomorrow is a good day again. Bye-bye.
Bye-bye.
Ciao. Stay blessed.
You too.